right? So where sender should know that what is the desired address, right? Where is the destination is present, or where is our user is present, right? So for that we are using a addressing. So maybe you ever seen that IP addressing in your laptop also, or any place, like mobile also, or whenever you are searching for any website, some local IP address is also there. It is basically 32-bit, right? So whole 32-bit is divided in four parts, right? 8888. So in dotted notation it is represented. So don't worry if you don't know anything in IPv4 IP addressing, I'll explain. So for device identification, we are using this IP address, right? I already discussed address is important, right? In real life also, as well as in networking also, right? So So IPv4 address is 32-bit long, right? So nowadays we are not using IPv4 addressing. Why? Because IP means if we calculate the total number of addresses possible, then more than only 4 billion. But in our World Wide Web, or what I can say in internet, so many addresses are there, right? So this is not sufficient, right? So nowadays we are using IPv6 addressing. But we will start from this basic one. Later on, we will discuss about what is IPv6, what is the difference between IPv4 and IPv6. So one basic thing, IPv4 is dealing with 32-bit address, right? So limited means previously it was used when our devices were limited, right? But nowadays it's not sufficient. Not for the yes, this IP address is use not for the host and router. For each and every devices we can use this IP address, right? Whenever we want to transmit something at that time, we are using. And it is not a permanent. Many times it's possible that sender is moving. Let's say sender is traveling from one place to other place, right? So at that time, the address is means permanent address is not possible. At that time some temporary address is allocated to sender. So okay. Now, if I want to discuss about address space, what do you mean by address space? So, total number of addresses used by that particular protocol that we can call as address space, right? So, let's say means basically where this IP address is used. IP address mostly deals with third layer, means network layer, right? In means first one is physical data link and network layer. So on third layer this IP addresses will work. And whenever data comes from above layer, let's say TCP layer, right? Or we can say transport layer. So whenever data is coming through the TCP, means transport layer is using the TCP, right? So whenever data is coming through that, at that time, to identify the data or identify the destination or intermediate node, we are using this IPv4 addressing. So you all know where it is used on third layer of our OSI layer, right? Now 32-bit address used in IPv4. So 2 raised to 32, this is the total number of addresses possible due to IPv4. But nowadays we are using IPv6, it is 128 bits. So 2 raised to 128 total possible addresses in IPv6. So let's say if I want to represent this IPv4 address, then first one, three types are there. First one is binary notation. Means what? This is the binary notation, right? 1010 form if I want to represent. And in between dot is also there. So this is total 32-bit IP address, 8888. It is divided in 88 parts, right? So second one is dotted decimal notation. Nowadays, or mostly we are using this dotted decimal notation, right? So if I convert this one into one and seven zeros, then it will convert as 128, right? So simply I converted it dotted decimal notation, right? So normally we are dealing with this kind of notation only, right? And third one is hexadecimal. Means if I convert this 128 in hexadecimal, then we can also represent like this. But in day-to-day life, whenever we are calculating something, means subnet mask or supernetting, means so many other concepts are also there. But whenever we are dealing with some calculation, at that time we are through this binary notation, but mostly we are dealing with this dotted notation, right? Now, uh, let's say here I took one example, or means how, what is prefix, what is suffix, right? So this is hierarchy of addressing. Means let's say this is one IP address, total length is 32-bit. This is prefix and this is suffix. Means mostly it is divided in two parts. What do you mean by prefix? Prefix means network ID address. Means prefix represent that in how many total number of network are possible due to this address. And what is suffix will represent nodes, means total number of nodes possible due to this address, that is represented by uh, suffix. Let's say I'll take one normal example. Let's say in Bangalore, so many other ward are there, right? Ward number is there. So let's say Bangalore is one network, then inside it, so many wards are there, right? 128 or 176. I'm not exactly sure, but let's say so many, more than 100 wards are there, right? So that all of that are small networks, and inside the network, so many other societies, other home, other houses are there, right? So that we can call as node, right? So if I want to connect it with real world scenario, then means one network, inside that some small network is possible, and inside the particular network small nodes are there, right? So whatever our houses and our society, we can call as node, right? One home is, one house is one node, and it is connected with one board number, right? So that is one network. So, if you don't understand that much, don't worry. I'll again discuss what is this, how you can calculate the IP address, what are the class, everything. So, basically, means first prefix part of the network will represent the network ID. Means through this particular IP address, how many networks is possible, and inside this network, through suffix part, we can decide that how many nodes are possible in that particular network. Now, let's say class full address, two types are there whenever we are dealing with this IPv4, IPv6, right? Anything. Class full address means what? Our network or our full address is divided in five classes: A, B, C, D, E. Five class are there. Class full, as the name suggests, we are dividing our network in class full address, different class. And classless means what? Simply we are assigning. In next class also I'll discuss what is classless address. Now, mainly five classes are there. First one is ABC, right? So, as what is this? 50%, 25%, 12.5, 6.25, 6.25. Means 50% means what? Total number of network or total number of addressing are there. Means let's say in world so many addresses are there. 50% of the network are occupied by class A, right? This is the distribution of each and every class. So if you'll observe carefully, this is the biggest class, right? A is the, then B is smaller than it, then smaller. While D and E are of same class, means length is same, right? Of class D and class E, it is 6.25, 6.25. Till now we are mostly dealing with class of ABC only. Class D will use for, mostly used for multicasting. What do you mean by multicasting? Multicasting means what? Let's say one sender is there. Sender wants to transmit that particular packet to so many other nodes. Then we can call as multicasting. So if I want to connect it with real life, then let's say one radio station is there, and listener are so many listeners are there, right? So one station means, let's say RJ is conveying something, so same thing is listened by so many other listeners, right? So one packet, if I want to distribute to so many other nodes, at that time we can call as multicasting. Mostly news are multicast. Many times you heard this word, right? Mostly your cricket matches are multicast, right? Casting. So one node is there that is transmitting the packet, and so many other node are there at a time, they are receiving the packet, right? So this class D is mostly used for multicasting, and class E Normally we are not using this class E because it is used for some security means for spatial use only, means mostly military person are using this class. For normal person we are not using this class E. Normally we are dealing with class ABC only, not D and E, that much. What is the 0, 10, 110, 1110 and 41? So this is the reserve bit of each and every class that I'll discuss how it is exactly distributing. Don't worry about it. And this is the exact range of each and every class. So first class A ranges 0 to 127, 128 to 191, 192 to 223, 224 to 239, and 240 to 255. This is the exact range of all classes. Let's say how we can identify. Let's say one IP address is given to us, right? 10.1.1.1, right? So I can easily compare the 10. It will come in comes under class 1, right? Because 0 to 127 is the range of class A. So 10 comes under here, right? Class A. Likewise, if let's say some other address is given like 200.5.5.5, right? So 200, first we have to check the prefix, right? 200, what it will represent, that it is comes under class C, right? Because range of class C is 192 to 223, right? So 200 will come over here. So likewise, whatever first digit is there or first 8 bit are there, from there we can identify that it will go under which class, right? So that's why we you have to know the exact range of each and every class: 0 to 127, 128 to 191, 192 to 223. Mostly this three class we are using in our day to day life. Now class A means exact range of class A is very big, right? 0 to 127. So 2 raised to 127 total networks are possible in class A. So that's why it is used in very big organization, or means very big institute, or where so many addresses are required at that time. We are using this class A. Class B is used, means class C normally we are using in our colleges, in our small companies. Class B, same thing, means smaller than class A and bigger than class C, right? So according to our need, let's say I'm one organization and I want my personal IP address, right? Or I want to host something, or I want my personal IP address. So at that time, let's say I'm CEO of company, and my means let's say 100 employees are working under me. So I want total 200 IP addresses, right? So for that I can definitely go with class C, right? So based on our need we are asking for particular class IP address, right? Now class D is used for multi-class multicasting, and class E reserved for future use, right? So mostly we are not using class E anywhere. Now two other concepts are there: subnetting and supernetting. So what do you mean by subnetting? As the name suggests, sub means what? We are dividing in small parts that we can call as subnetting. Let's say class A range is very much big, right? So if I want to divide my class A network in 4 parts, then what I'm doing, we can call as it's a subnetting, right? So divide the network into small parts that we can call as subnetting. So to reduce the wastage of IP address, right? So for that we are using the subnetting concept. And exactly opposite to it, supernetting means what? Combine more than one class based on the condition and requirement of subnetting. Means if I want to combine two C class, and I want to create, means I want to use like this, combining two C class, then also it's possible. So class combination and class division is also possible whenever we are dealing with this IP addressing. Now what are the advantages of our IP addresses? So easily identify, means we can easily identify, right? Because range is fixed. So from that I can identify, okay, this is class A address, class B address, class C address, right? And no extra information is added. Why? Because every time means fixed number of information I can send, 32 bit only. In that 32 bit, some bit for network ID and some bit for, means 32 bit, not 32-bit address is fixed, right? So no extra information, no need to edit, right? So through that particular 132-bit address, destination will easily understand, okay, this message is for me only, right? Now, this is whatever I discussed till now, means mostly in your exam they are asking the theory part. So whatever I discussed till now, that you have to mention in exam. So five classes are there, A, B, C, D, and this is used for this. What is subnetting? What is supernetting? What is hierarchy of addressing? This is important according to exam point of view. Now I'll show you the exact scenario of addressing. What is addressing, right? Or how this class is dividing and what is exact scenario, right? So let's say classful addressing. Now, no, before going to this, I'll explain this first. So how this class is exactly divided, that I want to show you. Let's say 32-bit address is there, right? Now, from that 32-bit, let's say all 0 1, I am using only binary digits, right? So 0 1 0 1 is there. Now, using this 32-bit, for half of the bit, if I'll use 0 first, and for half of the bit, if I use 1 first, right? Then what will happen? My network 2 raised to 32-bit network divided in two parts, 2 raised to 31, 2 raised to 31, right? For this half of the bits, I am keeping the 0 constant. So my network will start from 0, 0 1 0 0 something, right? So 1 will not come here, right? So 0, the 0 is constant whenever I'm dealing with this first type, right? So simply 2 raised to 32-bit network, I divided in two parts. So whenever I'm keeping 0 constant, and after that one, anything I can write 0 or 1, right? So that kind of network I can call as class A, right? So 2 raised to 31 total possible addresses, right, in this class A, right? So this is class A. Now, if I'll further expand this one constant, let's say here I'm expanding it. I'm keeping this one as a constant. After that, if I'll keep 0 over here, and in half of the part I'm keeping 1 1, right? I hope it is clear to you. Simply, what am I doing? First of all, 2 raised to 32 bits are there, right? So, and in dotted decimal, what I'm doing? I'm doing dividing in 8 parts, right? 8 8 8 8, right? 4 times 8 are there bits in terms of bits. Now, this 2 raised to 32 bit network, in that if I'll keep 0 as a constant as a first bit of each and every network, then it will comes under 2 A, class A. After that, for this 1111, if I'll further divide it in, if I put 0 over here, and in half of the network if I'll put 1 over here, then whatever 1 0 is there, constant bit I'm keeping 1 0, and remaining all bits, it's a variable, you can change it. But if I constant it this 1 0, then it will react as a class B. So total number of network possible is class B is 2 raised to 30. Means here 2 raised to 32 bit total size of the network. After that, I am dividing it in two parts, 2 raised to 31, 2 raised to 31. After that, if I'll further divide it in 2 raised to 30, 2 raised to 30. So if I'll keep constant as two bits, right, 1 and 0, that is for sure. It should be there. After that, it's user's choice, whatever user want to keep, right? So that we can call as class B. Now, same thing, same process I am following over here also. I am keeping this 1 1 as a constant, and after that 1 1 0. If I'll keep 0 over here, and in half of the part if I'll keep 1 over here, then this is class C. Whatever is containing 1 1 0 as a fixed number of bits, that is class C. After that, if I also further expand this 1 1 1, then what will happen? 1 1 1, and in half of the network I am keeping the 0 as a constant, in half of the network I am keeping 1 as the constant, then this will react as a class D, and this is all 4 1, then I can say it is a class E. So if you carefully observe that this is the biggest class, I'm further dividing it, and here I'm not dividing, further dividing, right? So I'm giving same equal priority to class D and class E, and this is the total number of network possible in class, each and every class. It's okay. Now I'll discuss one by one, means what is class A. So from this diagram you can simply conclude that whenever I'm dealing with class A, first bit 0, that is constant. Whenever I'm class B, whenever I'm dealing with class B, 10 is constant. Class C, 110 is constant. Class D, 1110 is constant. And class E, 41 is constant. After that, variable number of times you can add 0101. It's user's choice. So this is the fixed bit according to this IPv4 addressing. So same thing I discussed there also. Hmm. In previous example, whenever I was discussing, right? Here you can observe in class A, 0 is a constant, first bit 0. In class B, 10 is constant. Class C, 110 is constant. Class D, 1110 is constant. And class E, 41 is constant. After that, variable number of addresses is possible, right? So why it is constant, that I want to exactly explain to you why it is constant. Now, if I'll deal with class A, then I already discussed 2 raised to 31 IP addresses is possible, right? In class A. So the 0 is constant as the first bit. I already discussed in class A. First 0 is constant. After that, 7 possibilities are there, right? And 2 raised to 7 means in class A, this first 8 bit will represent the number of network possible, and remaining all bits, remaining 8 into 3 means what? 24 bits will possible or will represent host, number of hosts possible in that particular address. I hope it is clear to you, but am I making sense now? What am I explaining over here? How class A will work and everything? Yes, no.
Yes,
Hello.
ma'am.
Okay. In class A, first 0 bit is constant. After that, 7 possibilities are there. And first 8 bit will represent a total number of network possible. And remaining all 24 bits represent total number of host. So useful host in class A will be 2 raised to 24. This is total possibility, right? 2 raised to 24 minus 2. Why I am reducing this 2? Because this 2 IP address we are keeping as a constant, or we cannot use. We are keeping as a means for security purpose we cannot use first and last address of any network. So that's why total possible host is 2 raised to 24, 2 raised to 24 minus 2. And same thing applicable over here. Here 0 is constant, right? So 7 bits remaining, right? So 2 raised to 7 total useful network bits whenever I'm dealing with class full addressing, or class A, not class full, inside the class full, class A addressing. I'm keeping 0 as the constant, and 2 raised to 7 means 128 total number of network possible. So let's say in Bangalore, 128 ward is possible, right? Bangalore is one network. If I'll divide the Bangalore in small parts, then 2 raised to 7 means 128 total number of wards are possible. And what is this 24? Means in particular ward also, 2 raised to 24 house means up to 2 raised to 24 house we can assign the unique addresses, right? So 2 raised to 24 is 16 billion. Let's say in one ward, if we have 16 billion houses, then also till that we can assign the unique IP addressing through this class A address. I hope it is clear, but it's okay. If it is not that much clear to you, then also in computer networks too, you will detailed understand what is this exactly IP addressing. But still, I want to explain you means what is exactly IP. Now, if I deal with class B, then I already discussed in class B, 10 is constant, right? So I am keeping this 10 as a constant. And what is the second change I am observing over here? In class A, first 8 bit for network ID, right? And remaining all bits, 24 bits, I am keeping as a host ID, right? Now in class B, I am equally dividing, means 16 bit for network ID, 16 bit for host ID. So you can easily assume that here I am reducing the size of the class, right? Because only 2 raised to 16 possible host ID are there through this class B. And in class A, 2 raised to 24 possible host ID were there, right? So here my network bits is more, so number of wards in Bangalore, number of wards I am increasing, but in particular ward I am decreasing the number of houses, right? So likewise I am increasing the network number, but I am decreasing the host number. So here what am I doing? I'm equally distributing it, right? So 16 bit for network, 16 bit for host. So total number of possible network ID is 2 raised to 14, because 2 bits I'm keeping as a constant. I cannot do anything. So remaining all 14. So 2 raised to 44 is a network ID, and 2 raised to 16 is a host ID. But useful host ID is same thing, 2 raised to 16 minus 2, because first host address and last host address we cannot use. So two host address I am keeping as a constant, right? So this is the possible thing. Now let's say if I'll deal with class number C, then 3 bits are constant, right? I already discussed class number C. 110 is constant. One by one, what am I doing? I'm increasing the network number of networks. Here, 3 bits or 2 raised to 28. 1, 2, 3, and 4. I'm dividing my network in network address in four small parts, right? So in that 4 parts, first 3 part is for network ID. Means 2 raised to 24 network ID is possible whenever I'm dealing with this class C. And only 8 bit means 2 raised to 8 possible hosts are there whenever I'm dealing with class C. So I hope I'm making the sense. One by one, what am I doing? In class A, only first 8 bit is for network and remaining all for host. So number of host is more in class A. In class B, I'm equally dividing 16 bit for network ID, 16 bit is for host ID. In class C, 2 raised to 24 means one by one I'm increasing the total number of networks. But inside that network, host ID I'm decreasing. So here 2 raised to 24 total network possible, and 2 raised to 8 is total host possible in one network, right? Class D, no network ID, no host ID concept, right? So simply we are not using, mostly we are using for multicasting. For multicasting, simply you can assume this scenario of radio, right? Means one RJ is speaking something and so many other nodes or so many other listeners are listening to him or her, right? So same thing, one packet, if I want to spread in whole network or 2 3 networks at that time, I'll use this class D. Then class E, same thing. Class D in E mostly used for multicasting. For future use, we are reserving it, right? Now, multicasting I already discussed, but still I'll discuss casting. Two types of casting are there in IPv4 addressing. First one is unicasting, second one is broadcasting. Unicasting means what? One host to one host, right? Mostly one source, one destination, one sender, one receiver, right? That I can call as unicasting. Means only dedicated link, right? One sender, one receiver. And broadcasting means what? Or multicasting, same thing. One host and many, means one sender and other side, so many other hosts are there, right? So let's say this is unicasting. This is my network 11.0.0.0. This is my network ID. Inside the network 11.1.2.3. This is my host ID. Host, right? This is my host. Same thing is applicable over here. 20.0.0.0. This is my network ID. This is whole network. Inside the network 20.1.2.3. This is host ID, right? So if This too will whenever this host want to transmit something to this particular node only 20.1.2.3, then we can call as unicasting, one to one communication, right? But in broadcasting, let's say 11.1.2.3 wants to broadcast something to whole network or other network also, right? So limited broad, two types are there of broadcasting. First one is limited broadcast and second one is directed broadcast. So whenever I want, this is source address, right? 11.1.2.3, right? This is source address, and destination address. If I'll keep 255.255.255.255, then it is limited broadcast address. Means it will broadcast in whole network directly, right? It will broadcast. Means one broadcast as well as other broadcast also. I'll discuss. Wait. In directed broadcast, what we are doing, this 11.1.2.3, right? This one particular network wants to transmit something in other network, same broadcasting process but not in their network. In other network, if they want to broadcast something, then we can call as directed broadcast. And simply, in particular network, if sender wants to send something to each and every node in particular network only 11, this is a host of 11.1.2.3, right? This is the host id, so network id is 11. It is class A, right? Obviously it is comes under 0 to 127, so class A. And this is the network id 11.0.0.0. This is network id. So whenever user want to transmit something in particular network only 11.0.0, at that time it will use to directly to destination address as a 255.255.255.255. But similar way, directed broadcast means what? The 11.1.2.3 is the network, and this one means in other network 20.0.0.0. In other network, if this particular node wants to broadcast something, at that time it will use directed broadcast. I hope it is clear to you, but it's okay. After that, I calculated so many subnetting concept and network IDs, how many possible network IDs, how we can divide it in proper subnets and everything. It's not means if I'll explain you that you will definitely not get it. So it's okay. Uh, I'll show you the virtual lab how it is exactly work. Now, uh, this is the link of virtual lab. I hope it is visible, right? Uh, Our IIT is organized so many virtual lab concept over here. Means this is our subject code. For that subject code, how many? What are the basic concept? And this is the link for that particular virtual lab. So for data communication, our subject code is 18CS46. For that particular means particularly they haven't mentioned any subject or anything because in our subject no lab are there, but still some computer network basic concept lab is there. So I'll explain from that only. Fundamental of computer networks, that is there. I'll show you. Fundamental of computer networks. Yeah, this one 18CS52 fundamental of computer networks, right? So if I'll open this link, then it is showing me IPv4 addressing, whatever. Okay, whatever I discussed today, right? So if I'll open this, here they mention the aim of it, that to give IP address of different class in the network ID. So this is the aim. Here they discuss the theory part, whatever I discussed till now: class A, class B, class C, class D, class E. 5 type of classes are there inside the class. This is the range they have discussed: 1 to 127 or 0 to 127 is also fine. This is the range also given. This is the first address, last address, and you can read these. I'll also share this link with you people. But the main thing I want to show it here is, after that they mentioned the pre-test, right? So here they mentioned for three MCQs. So first MCQ is which IP address is automatically assigned to DHCP server. DHCP server till now I haven't discussed, but this is basically means whenever any node wants the dynamic IP address, at that time it will use this dynamic IP addressing. Mostly mobile phone and other means moving device or mobile devices will use this DHCP server or will use this dynamic IP address because it is moving. But for LAN connection, for means whatever PC is connected with LAN, for that we can directly assign the static IP. Likewise, they mentioned some of the MCQs. After that procedure, okay, no need to read. After that, simulation is there. The main thing I want to show you is simulation. Means if I'll click on it, they'll show me this kind of screen. In that, if I carefully select what they mention, choose the class in which the IP addresses is to be done, right? So choose the class A. If I submit, then they'll give me different IP addresses, given IP address for the following computer with the network IDs 1.0.0.0 in class A. Means if you likewise, you can also give here also IP address and subnet mask also. If you will do like this, then they'll evaluate or they'll match it with class, whatever class you selected. Let's say here you selected class C and you are giving the address of class B. Then if you after that, if you click on evaluate, then it can easily say that PC1 is not a network, means that particular address is there in your network or not. So likewise you can check for different networks, right? So here whatever they are showing over here, that is by default or already entered value, right? So every time they are showing different values and they are mentioning that this is inside the class, this is not the inside the class, likewise, right? So any problem till now, whatever in this virtual lab, after that post test also is there in that 5 MCQ they mentioned. So you can give the answer of this MCQ if you want. Now any query?